All right, now we're back for domain 5, data protection. Before we get started, remember to like, subscribe, and share this with anyone else you know who's going to take the AWS Security Specialty Exam. So we're going to go over some questions, some answers, and diagnose with some supporting documentation why the answer was correct and why it was incorrect, or why the incorrect answers were incorrect. Let's get started. Security team at a company is working to create VPC endpoints so the AWS Systems Manager can be used to manage private EC2s without internet access. Which options would you combine to build a solution to meet the right requirements? So A, B, and D. So this is going to be create identity access manager instance profile for systems manager, attach the IAM role to your private EC2, verify, then B, verify the SSM agent is installed on the instance, and then D, create 3 virtual VPC endpoints for Systems Manager with the service names com.amazonaws.region that you're in, .ssm, .ec2 messages, .ssm messages. All right, so why are these correct? So Systems Manager requires 3 specific VPC endpoints for full functionality without internet access. The IAM instance profile provides necessary permissions, and the SSM agent must be installed for the services to work. Okay. So let's see. Let's try this. All right. So here's going to be the answer, right? Doesn't have internet access. How do you use Systems Manager, right? Create the IAM profile. Make sure the instances are there. Set up the IAM instance profile. Attach the IAM role to the instance. Open the EC2 and select that instance, okay? And then configure the VPC endpoint. Well, that's going to be a part of it with the following VPC endpoints. Okay. To Systems Manager. Let's see this one. Here we go. All right. com.amazon.aws and then the region, SSL. That region is a variable, okay? And then EC2 messages, and then down here, SSM messages, okay? So this is for the endpoint for the systems manager. Systems manager uses to make calls from the SSM agent to the systems manager service, and then this is for the SSM agent to communicate with systems manager for run command. Okay. All right. Sorry for my Terraform documentation, but that's another project I'm working on. All right, next question. Okay, a procurement application connects to Amazon API Gateway REST API for its core functionality needs. The development team at the company wants to restrict access to allow only specific public IP address ranges of the company's selected vendor systems to access this public API Gateway REST API. What configuration is needed to restrict access to the API Gateway REST API? So the answer is A. All right. So create a resource policy for your REST API that denies access to any IP address that isn't specifically allowed. In the resource policy for AWS SourceIP, give the value of the specific public IP addresses that you want to grant access to. Okay, so why is this correct? AWS SourceIP condition works for public IP address ranges and can effectively restrict access to specific IP addresses through a resource policy that denies all other access. Okay, so why are the others incorrect? I forgot to do that with the first question. My apologies. Okay, so AWS VPC source IP, this is a condition for private IP addresses, not public IP addresses. And then let's see, the Amazon API Gateway, REST API does not support specific specific resource policies. So this is incorrect. REST APIs do support resource policy. HTTP APIs don't. Okay. See, that does not. All right, that's what makes it incorrect. Okay, so VPC endpoint policy. So this is for private APIs, not public APIs, as specified in the use case. All right, let's go for some. Let's see. Let's find source. Hmm. source IP. Maybe we'll hear. Okay, so there you have, all right, AWS source IP right here. All right, and this is the resource policy for this. So the source policy works only for public IP addresses. So to allow this, use VPC source IP condition. Oh, I'm sorry. So this goes into the private. For source IP, you can replace that with the site IP addresses you want to grant access to. Okay, and specify it for a range of IP addresses. For the example of the public IP that's listed, and then you see 3 different IPs. Okay, and VPC source IP is for the private address. All right, let's save that. Okay, next question. The company stores its critical business data on S3 buckets. A customer does not use TLS versions 1.2 or higher, and hence is unable to access content stored in Amazon and S3. How will you set up a solution to allow the customers to access content in the S3 buckets using TLS 1.0 or 1.1 while keeping the communication channel secure? So this is CloudFront, okay? So create a CloudFront distribution with origin access control. Make your S3 private and configure access through CloudFront only by using signed requests to access the S3 bucket. So why is that correct? Okay, so CloudFront abstracts customers from the TLS protocol used between CloudFront and S3, allowing older TLS versions while maintaining security through origin access control. So let's see. So this is an overview that you can go into, but let's see if we can find some more specific. Okay, so this is going into it. All right, CloudFront provides ways to send requests, origin access control, and origin identity. So we're going to go to the origin access. Okay, let's see. So use CloudFront with S3. You must set object ownership. And okay, use OAC to secure your S3 origin. Communicate between CloudFront and Amazon S3 is always through HTTPS, but only when you choose to always sign requests. You must choose sign requests. Okay, so that goes into it a little bit more. And then CloudFront principal. Let's see. Let me see. Okay, so use OAC because it supports the following features. S3 buckets, including opt-out regions, server-side encryption, KMS, dynamic requests. Okay. Delete integrating. Use OAC. Set it up. OAC 2. So this is not specifically stating it anywhere I'm seeing it. So this is about encryption, and this is how you would do it. Let's see, for cloud formation, use the CloudFront origin access control. Delete distribution, no. No, it's not specifically here. Let's see. So, okay. So this might get it to continue up there all uses. So this actually answers the question in a different way, but it goes towards TLS, right? So it suggests updating from TLS 1.0, 1.1. All right. And then it does go into this. So let's see if we can find. So the OAC authenticates the viewer's requests. And then let's see if we can find. So bucket. Let's see if we got TLS. Okay. Okay, so this is, okay, to control specific policy, must get a custom domain with a certificate and allows customers to use TLS from right here. Okay, so that's part of the security policy. And then, okay, so this looks like it goes a little bit more into it. So this uses, makes a request using TLS, connects to it, and successfully downloads it. So you can use the security policy to connect to it. So this answers around it, but it's not 100%. But this is the suggested path you go to. Now, why are the other answers incorrect? Okay. So Custom origin. All right. So a custom origin can't use OAC or OAI, right? Can't use that origin access. Why is that? Because it reduces security, basically. All right. And then the wildcard. Okay. So the wildcard domain name. So this is irrelevant to the question or to TLS version limitations. So wildcard certificates don't solve TLS protocol issues. And then let's see, bucket policies. So a bucket, so this can't allow insecure TLS versions via the bucket policy. AWS enforces 1.2. So that CloudFront abstraction helps with solving that. All right, let's go to the next question. All right. The company uses CloudFormation templates to provision all of its AWS infrastructure resources. One such CloudFormation template needs to provide the username and password as credentials to the newly created Amazon Redshift database, which is the optimal way to configure the database credentials during the stack creation without compromising these credentials. So this is saying the answer is A, right? First, create a secret with the password generated by a secrets manager. Then use a dynamic reference in the CloudFormation template to retrieve the username and password from the secret to use as credentials for the new database created. Sounds good, right? So dynamic references allow CloudFormation to retrieve secrets without hard coding the credentials. So this maintains security and enables automatic credential generation and rotation. All right. And then we can put some supporting, let's see, this should be good. All right. So this is CloudFormation, lets you retrieve a secret to use in a CloudFormation resource. That's it. That answer is right there. Set the secret with the password generated, then retrieve the username from the secret from the database. This is the answer. Okay. So why are the other answers incorrect? Okay. So let's see. So let's see. This resource metadata. No, that's not. So you can't use dynamic references and metadata like CloudFormation in it because it makes secrets visible in the console. And then encrypted templates. So this is a made up solution, right? This is a distractor. So templates cannot securely encrypt credentials within them. All right. And then let's see, dynamic reference using the backslash. Okay, so this is invalid syntax. Okay, so CloudFormation cannot resolve references ending with backslashes. Okay, so look at the small pieces that kind of try to trick you up. All right, let's go to the next question. Okay, company wants to secure the objects in S3 using server-side encryption, subject to the constraint that the key material must be generated and stored in a certified FIPS 140-2 Level 3 hardware service module, an HSM, that the company manages itself. In addition, the key material must be available in multiple regions. The size of objects in S3 ranges from 15 kilobytes to 5 megabytes. Which of the following would you recommend? This is going to be A, right? So leverage the KMS custom key store backed up by the AWS Cloud HSM clusters, and then copy the backups across regions. Okay, so why is this correct? So custom key stores use customer managed HSM clusters, and these meet the FIPS 140-2 level 3 requirements. Okay, and then HSM backups can be copied across regions for multi-availability while maintaining customer control. Okay, so let's go through the other ones, why they're incorrect, because it's very close across the store. All right, so this was the S3, okay? So you can't store KMS key material in S3. Customer managed keys use AWS managed HSMs, not customer controlled ones. And then why is this one incorrect? Okay, so key replication. Okay, so AWS uses managed HSMs, not customer controlled HSMs. Again, all right, so it's managed, not custom. All right, and then HSM with copy backups across regions, use SDK to encrypt and decrypt. Okay, so encryption SDK provides client-side encryption, but the requirement specifies server-side encryption. All right, and let's go into, let's see, copy the backup, HSM clusters. All right, so this is gonna be it. All right, so you can copy HSMs across from many regions for resilience, global workloads, and disaster recovery. All right, and then this is good on how to do this. So copy this from the destination. The account must have policies, IAM policies. Yeah, and then it has to allow access to it. You manage the clusters independently. Backups cannot be copied between restricted regions and standard regions, but they can be copied between GovCloud from US East to US West. Okay. So this example, this is basically explicit permissions of how you can do this. All right. Let's go to the next question. All right. The security team at a company has been assigned the responsibility of configuring outgoing email using Simple Email Service, SES. And that leverages the Amazon SES API with the mandatory TLS for the secure transfer of data. What configuration would the engineer choose to make TLS mandatory for SES API? So this is saying it's A, change the behavior of SES by using configuration sets, then set the TLS policy property for configuration set to require. Okay, so why is this correct? So by default, SES uses opportunistic TLS. To mandate TLS, you must use put configuration set delivery options API to set TLS policy to require this in the configuration set. Okay, and then let's see. Okay, so let's see. TLS policy. Okay, so you can change. Okay, so while TLS is the default, SES can deliver mail using earlier versions. By default, Amazon SES uses opportunistic TLS, which means SES always attempts to make a secure connection to receive it. But if SES can't establish a secure connection, it sends a message unencrypted, which you don't want. So you can change it by using configuration sets using put configuration sets API to set the TLS policy property. Boom, that answers it. Okay, so why are the other ones incorrect? Okay, so let's see, start TLS. Okay, so start TLS or the TLS wrapper. Okay, so why are these? So these are SMTP, these are simple mail transfer protocols. These are not applicable to SES's API usage, neither B nor D. All right, and then the default SES configuration management. Okay, so that's incorrect, right? We just showed you. SES uses opportunistic TLS and might go unencrypted. It's not mandatory. So you need to make it mandatory. All right, and we just showed you some of that supporting documentation. Okay. So next question, a business maintains its business critical customer data on an on-prem system in an encrypted format. Over the years, the business has moved from using a single encryption key to multiple encryption keys by dividing the data into logical chunks. With the decision to move all data to the S3 bucket, the business is looking for a technique to encrypt each file with a different encryption key to provide maximum security to the migrated on-prem data. How will you implement this requirement without adding the overhead of splitting the data into logical groups? That's server-side encryption. Okay, so, oops, okay, so it's A. Golly. Okay, A, configure a single S3 to hold all data. Use server-side encryption with S3 managed keys to encrypt the data. All right, so why is this? So S3 automatically encrypts each object with a unique key, meeting the requirement without data splitting overhead. And S3 manages unique keys per object automatically. So let's go through why the other ones are incorrect. Okay. So multiple buckets. All right, let's see why this is incorrect. All right, this adds a lot of unnecessary overhead. When a single bucket with the S3 or the single server-side encryption for the S3 achieves the same result. Let's see, client-side encryption. No, the server. Let's see, yeah, client-side encryption. All right. So this is categorically wrong. You should see this right from here, right? It says server-side encryption. All right. This is what we're trying to do, to encrypt each on-prem without adding the data. This is data to the S. Maybe it didn't say it. Okay, but I know that the S3 SSC S3 is the way to go. I thought it said it in the question. My apologies. And then the final one. Okay, so the SSE KMS with encryption. So encryption context provides additional security, but it doesn't generate unique keys per object. S3 can do that. All right, so let's see. Okay, S3, applies server-side encryption with S3 managed keys as a base level for encryption for every bucket in here. And then since January 2023, all new objects uploaded are automatically encrypted at no additional cost and no impact on the performance. There it is. That's right there. Okay. So document it for yourself. Next question. Okay, security engineer must ensure that all certificates imported into the AWS Certificate Manager in all AWS regions must be notified of expiry 30 days before their actual expiry via a single notification to the security admin. The notification, along with the certificate information, should be sent to the security admin and the security hub for centralized management. Which steps must be taken to perform these tasks optimally? This is saying A, okay? Configure days to expiry CloudWatch metric to schedule a batch search of expiring ACM certificates and trigger a Lambda function to send the certificates to be expired notification to an SNS topic. So this Lambda function can also be configured to log all the expiring certificates as findings in Security Hub. So why is this correct? So this is a scheduled solution, and it provides a single consolidated notification for all expiring certificates across regions. And it logs the findings in Security Hub and can be deployed across multiple regions for comprehensive coverage. Okay, so why are the other ones incorrect? Okay, so the Security Hub built in, that's close. But okay, Security Hub can monitor certificate expirations, but it's regional and it requires a complex setup across multiple regions. So it doesn't provide a single notification. Then let's see, Event Bridge. Okay, so this creates separate notifications per certificate rather than a single consolidated notification as required. Okay, and then config. Okay, so this is good. So config is great, but config cannot automatically renew imported certificates. It only detects the expirations, and it also doesn't send. Right, you'd have to add extra operational overhead to make that really work. Okay, let's see. Okay, so there's a built-in ACM event, which is raised through Event Bridge to the local Lambda function. I think we just covered that, right? Publish the results in Security Hub and an SNS topic, used for an email subscription, and admins can be notified automatically, right? And then the next one, which doesn't answer it, but this is not the correct answer, right? Use the date to expiry metric to schedule a batch search and then log all the findings. So this can kind of do it partially, but then the metric could provides a single SNS notification. So those kind of both work hand in hand. Okay. All right, next question. Development team at a company accesses resources all across all AWS regions. The management wants only the security team to have access to resources from all AWS regions. Any access to members of the development team needs to be restricted to the resources in a single AWS region, so US West 2, except for the global AWS services. The development team is sized at 40 members, with all members being part of the developers IAM group. The company needs to implement this access restriction immediately. What's the optimal way to do this? So this is saying it's A. So create an identity-based policy with the IAM policy, AWS requested region condition key that denies access to all actions outside the specified region, except for actions related to the global AWS services specified in using not action. And then attach the policy to the developers IAM group. Okay, so this is correct. Why is this correct? Okay, so AWS requested region directly addresses the regional access control. The not action exempts global services that physically operate in the specified region, okay, or the global regions, right? So this is the most direct solutions. And why the other ones not? Okay, so service control policy. So this requires AWS organizations. So, and this isn't really mentioned in the use case. So you want to answer the question directly as possible. Tag based. Okay, let's see. Why is this incorrect? So this is more complex than when needed, right? So when you're doing a direct regional condition, this is adding additional complexity. It could technically be done, but you want the optimal way to meet the requirement. And then source IP policy. So IP-based restrictions don't align with regional resource access requirements. So while I don't know if you could even do that. I'm trying to think that, oof. Okay, let's see if we can get some documentation here. Okay, so this would be, yeah, this would be it. Okay, so this is a good example showing it. And then you'd show deny outside of all requested regions, deny CloudFront, IAM, organized, wow. And then an AWS requested regions, US, EU. Yeah, so there you go. That would be the good example of how to do that. Okay. Next question. A security engineer has been asked to configure an interface VPC endpoint to access Amazon API Gateway private REST API that is in another AWS account. What are the key points of consideration while creating an interface endpoint in the Amazon VPC account for the requirement? Okay, here we go. It's A and B. All right. When you activate private DNS for an interface VPC, you can no longer access API Gateway public APIs from your Amazon VPC. And the security groups that you choose must have a rule that allows TCP port 443 inbound, HTTPS traffic from the IP address range in your VPC. Why is this correct? Okay, so private DNS causes public API calls to route through the VPC endpoints, which only support private APIs, resulting in 403 errors. Okay, and then security groups must allow HTTPS traffic for the endpoint to function. Why are the other ones incorrect? And we'll show some documentation. So let's see. Okay, so to connect public APIs. Okay, so this is impossible. VPC endpoints only work with private APIs. Okay, and then multiple subnets. So this is a good practice, but it's not mandatory, right? If you just want this to meet the requirements, and these two go together in our requirements. Okay, and then on-prem networking. So this is incorrect. So you can access private APIs from on-prem using public DNS via Direct Connect. All right, and let's see some. Okay. Oh, there we go. So this will probably have it. Okay, so yeah, there you go. Confirm private DNS is turned on for an interface VPC endpoint that's associated with the VPC, right? And then let's see if we can find some security group information. So these have optional things that can come along here, like I was pointing to. Why am I not seeing security group? Okay, there we go. So boom. Oops. So security groups for your VPC allows the traffic to your API. Well, that's not exactly what I want. Hmm, this is not quite what I'm looking for. No, let's see if this is. Let's see. Let's see if this has it. Basic security group rules, security group examples, multiple VPCs. It's not it. No. Let's see. So this would be, man, so this is getting there. Hmm. Curl. No, no, it's not saying here. All right, I can't find this one. But I know that that is required for it to actually go. For impound, TCP on that network layer. Yeah, that is what is needed for the security groups. Okay, let's go to the next question. Sorry for that. Okay, so an e-commerce company is designing a multi-account structure for its finance and operations team using AWS organizations and AWS single sign-on. The team should only be able to access specific AWS services in the designated AWS regions. Which solution will implement these requirements with the least operational overhead? This is going for A, create service control policies that deny access to any operations outside of the designated AWS regions. Apart from the condition and resource elements, configure the not action element to allow access to the required AWS services. So why is this correct? So service control policies with regional denial and service exemptions via not action provide centralized control with the least operational overhead, because not action exempts global services that operate in that region. Okay. And then let's quickly go into why the other ones are incorrect. Okay. So this is deny list policy. Let's see this one. All right. Oops. Okay. So the deny list policy. Golly. All right. So the deny list policy, right, with the admin exclusion. So this, you cannot exclude admins from service control policies. Service control policies apply to all principals in member accounts. All right. The MFA mandate. So this is MFA is always good to have implemented, but it doesn't solve regional or service access restrictions, right? That's an account issue. And then create an SCP for users. So SCPs don't grant permissions; they only set boundaries. So this would be something that would require additional IAM policies, which is what this is trying to target. Okay. All right. So SCP denies access to operations outside of specified regions. So you can replace this and use it however you'd like to. All right. And so in this, you could deny all outside EU, call it that for deny. And these are all the things you would be denying, right? And then not equals the requested region, EU Central and EU West. Boom. And then here's the ARNs that are not like this, allowed to bypass. Okay. So this addresses that answer pretty head on. All right, next question. The user is trying to upload a large file to S3 present in a given AWS account. In the upload request, the user is passing the encryption information using a key management service key, also present in the same account. However, the user is getting access denied error. Meanwhile, when the user uploads a smaller file with the encryption information, the upload succeeds. How will you fix this? Okay, so I know this. KMS decrypt. This allows for reads. So this is a permission specified in the key policy. Otherwise, they would need to be added to the policy. So why? Large files trigger multiple or multi-part uploads, which requires KMS decrypt permissions to decrypt uploaded parts before assembly. Since small files work, KMS generate data key is already present, so that means it's partially working already, but you need to add that decrypt on the back end. Okay, so why are the other ones incorrect? Okay, so let's go for this one. All right, so KMS decrypt. Okay, so the only key policy. All right, so this is KMS decrypt and IAM. Okay, so only the key policy is needed when the key and role are in the same account. So this would be overkill. You could technically do it, but you're wanting to answer the question directly. The KMS encrypt. So this is used for small plain text encryption, like up to 4 kilobytes, I want to say. So this isn't relevant for an S3 multi-part upload. So you have to know more about the encrypt, decrypt permissions to understand why this wouldn't be relevant. And then generate data key. So this is already present because you can do the smaller uploads, which is baked into the original question. All right. And then let's get some. Confirm you have decrypt actions on the KMS key that you use to encrypt the actions. For larger files, S3 commands with this. And to use KMS key to encrypt the multi-part upload, you must have generate data key, KMS decrypt. And the decrypt permission allows you to encrypt newly uploaded parts with the key you used for previous parts of the same object. That answers it. All right, next question. All right. A financial services company is revamping its technology solutions on AWS to meet the company's new security guidelines that mandate the use of the company's own imported key material to create customer master keys to be used with the AWS service. All encryption keys must also be rotated annually. How will you implement this requirement? The answer is A, create a new customer master key and import the new key material into it. Point the key alias of the older CMK to the new CMK created. So why is this correct? So KMS keys with imported material cannot use automatic rotation and cannot change key material once imported. Manual rotation via aliases allows applications to use the same alias while pointing to different keys. Okay? All right. So why are the other ones incorrect? So associating a different key material, you can't import different key material into existing KMS keys. See, there's a difference between the existing and creating a new and importing new. All right, delete the old key. This is going to be a problem. Okay, so KMS requires 7 to 30 days for deletion. So this would prevent an immediate recreation. And then automatic rotation. So automatic rotation is not supported for KMS keys with imported key material. Okay, and then let's see if we can get some supporting. And change your applications. Yeah, you can change your applications or aliases to use new KMS keys, or you can rotate the key material associated with an existing one by enabling automatic key rotation or performing on-demand rotation for the customer managed keys. Okay, and then you can track. Let's see. All right, see, so you might decide to create a new KMS key and use it in place of the original. This has the same effect as rotating the key material in an existing key. So it's thought of as manually rotating. And manual rotation is a good choice when you want to rotate keys that are not eligible for automatic or on-demand rotation, including asymmetric, HMAC, KMS, and multi-region keys. There you go. All right. All right, next question. All right. The company uses an S3 bucket to store its business critical data. Recently, all the members of the development team that access the given S3 have been given MFA devices. A security engineer must configure permissions such that access to the given S3 is allowed only after MFA authentication. How will you implement this requirement? All right. The answer is A. So let's walk through this. Create an IAM group having the development team users. Add a customer managed policy with a deny effect to the group for all S3 actions with the condition defined as condition. Bool if it exists. So if this exists, right? AWS multi-factor authorization is present equals false. Okay, so let's walk through this. So the bool if exists with a deny effect and a false value denies requests without MFA. So if MFA is false, if it doesn't exist, it's denied. Okay, so this includes any requests made without MFA, including long-term credentials. So this is the most secure MFA enforcement. Why are the other ones incorrect? Okay, so the bool alone, right? Bool alone. This only applies to temporary conditions, and it doesn't deny long-term credential access. Okay. Allow with bool. Okay, so bool if exists, and then allow, right? That's true. Okay, with an allow effect. Okay. So this allows both MFA and non-MFA requests. It defeats the purposes. So allow if MFA is present. Yes, but it doesn't have a deny effect. You know, and deny can override allows. All right. And then bool if, all right, so allow effect, bool if exists, false. Okay. So this allows non-MFA requests. This is the opposite of the requirement. So read this carefully and understand what you're trying to do with a negative, positive, and whatever else you're trying to configure. All right. So we'll go to the next question. All right. Security team at a company needs to implement a client-side encryption mechanism for objects that will be stored in a new S3 bucket. The team created a CMK that is stored in AWS Key Management Service for this purpose. The team was able to successfully get existing objects from the S3 while testing, but any attempts to upload a new object resulted in an error. The error message stated that the action was forbidden. Which IAM policy action should be added to the policy to resolve the error? Generate data key, okay? So why? So generate data key creates unique symmetric data keys for client-side encryption outside of KMS. This is essential for uploading new encrypted objects. Remember what we covered earlier? Okay? But that was more specific towards, the multi-part upload. Why are the other ones incorrect? Get public data key. Okay, so get public data key is for asymmetric keys only, and it's not applicable to client-side encryption with symmetric keys. Okay, does that make sense? And then client-side encryption and get key policy. Okay, this retrieves key policies, and it's not related to encryption operations. And then get data key, that's just a made up. I mean, I've looked at this before, and then yeah, there's some stuff out there for trying this, but that doesn't actually exist. All right. Okay. Next question. A media company stores all of its business data on S3s. Since a massive growth in the number of customers has resulted in complicated bucket policies, the company has now hired you as a security specialist for simplifying the S3 buckets configuration to facilitate access for the company's customers, as well as other connected applications. What are the important configuration characteristics to consider while defining access points for the S3 buckets? So this is going A, B, and C. All right. You can only use access points to perform operations on objects. You can't use access points to perform S3 operations like modifying or deleting buckets. The cross-account but access points don't grant access to data until you're granted permissions from the bucket owner. And then you can't configure cross-region replication to operate through an access point. Okay, so why are these correct? So these are the fundamental limitations of S3 access points, right? There's object level operations only, cross-account permissions have a dependency, and there's replication restrictions. Why are the other ones incorrect? Okay. The HTTP, HTTPS. All right. Oops. All right. So access points support HTTPS only, not HTTP. Why's the other one incorrect? Okay, it's aliases. Aliases cannot be used for CloudTrail or S3 server access logs. And then why is the VPC configuration? So you can't change VPC configurations after creation, right? You can modify some pieces of it, but you can't really change it, right? So it's not it's a console. I mean, it's a console limitation, and it's very difficult. It's very difficult to do anything like that. You're better off creating it all from scratch in the first place. All right. So let's go for the next question. Okay. All right. The security team at an IT company has recently migrated to AWS, and they are configuring security groups for their two-tier application with the public web servers and private database servers. The team wants to understand the allowed configuration points for an inbound rule for a security group. Which of the following would you identify as an invalid option for setting up such a configuration? The answer is A. Okay. So you can use an Internet Gateway ID as the custom source for the inbound rule. Okay, so why is this correct? So Internet Gateway IDs are not valid sources for security group rules. Security groups support IP addresses, CIDR blocks, security groups, prefix lists, but not gateway IDs. Remember, invalid. Okay, so why are the other ones incorrect for this answer? All right, security groups as the source. Okay, these are allowed, right? This is allowed with security groups. All right, CIDR blocks. This is valid. This is a standard way to specify IP ranges. And then an IP as the custom source. You can always use an individual IP for security groups. All right, and then we'll go here. All right. Security group rules. Oops. Those are basics, components. Okay, so here's the sources. Okay. These are protocols, source of destination. Okay. Prefix. right? IP addresses, prefix, ID of a security group. Oh, and CIDR block, obviously. Okay, that's it. Okay. And then next question. Okay. A healthcare company only operates in US East 1 and stores encrypted data in S3 using SSE KMS. Since the company wants to improve the backup and recovery architecture, it wants the encrypted data in S3 to be replicated into the US West 1 AWS region. The security policies mandate that the data must be encrypted and decrypted using the same key in both AWS regions. Which of the following represents the best solution to address these requirements? So this answer is going to be A, all right? Set up a new S3 in US East 1 with replication enabled from this new bucket into another bucket in US West 1. Enable SSE KMS encryption on the new bucket in US East 1 by using the AWS KMS multi-region key. Copy the existing data from the current S3 in US East 1 region into this new bucket in US East 1 region. So why is this correct? So multi-region KMS keys allow the same key to be used across regions. Since existing data was encrypted with a single region key, it must be copied into a new bucket configured with multi-region keys for proper replication. So why are the other ones? Okay, so share the existing KMS. Okay, you can't share a KMS key across regions. Region keys are region specific. This is for compliance, regulations, encryption. This is baked into AWS. You need to know your well architected framework. All right. Okay, so go from single region to multi-region. So you can't convert existing single region keys to multi-region keys. That's no, they can't do that. And then a Lambda schedule. Okay, so having a daily frequency on something like this would create a significant amount of data risk and would add a lot of complexity compared to something like natively using S3 replication. It's overhead. It's complex overhead. All right, next question. The social media company wants to block access to its application from specific countries. However, the company wants to allow its remote development team from one of the blocked countries to have access to the application. The application is deployed on EC2s running over an application load balancer with AWS WAF. Which of the following solutions will you combine to address the given use case? This is going to be A and B. WAF geolocation matching statements to list the countries you want to block, and then WAF IP set statement that specifies the IP addresses that you want to allow through. Why is this correct? So WAF has a geo matching statements that can block specific countries. You can also allow them. And then the IP set statements can whitelist specific IP addresses for the development team. So these can be combined in WAF rules to achieve the required access control. So why are the other ones incorrect? So the NACLs, all right? NACLs can't filter based on geographic conditions, only IPs. So it's a very difficult and hard to scale solution. And so the load balancer responses, okay? So load balancers operate at layer 7 for routing, but don't provide, or the application load balancers, excuse me, don't provide geo blocking or IP filtering capabilities. These are WAF features. So these can be worked with together, but these don't answer the question at all. Okay. Yeah. Okay, so introducing console, right? So use geomatching statements with web requests on countries of origin. Adds labels to the request of origin. This is good. So you can use the geomatch statement for country and then region it. Okay, that's a good one. Okay. And then, yeah, this one does as well. Okay, and then inbound traffic against access control list. Let me see on the IP portion. Okay, applies geographically. Okay, JSON file has a section where you can list IP ranges that should be blocked. Right, but where is the part where you say IPs can be allowed? IP addresses, conditions. Applying. We'll find it. We'll find it. Huh. You can list IPs that should be blocked. So it should have the section where you can say they could be found. Okay. WAF determines country, blocks by use the IP of address, origin, configurations, IP. Oh, maybe it's this. So this is going to be about blocking main independent list on this. Where is this? Web requests against a set of IPs. This uses to allow or block web requests based on the IP addresses. There you go. All right. Okay, go to the next question. All right. A healthcare company has recently completed a security review that has highlighted several gaps in the security standards mandated by the company while using the AWS KMS keys. As an initial step to address the gap, the security team has decided that access to AWS KMS keys should be restricted to only the principals belonging to their AWS organizations. How will you implement this requirement? Let's see. A. AWS Principal Org ID global condition key can be used with the principal element in a resource-based policy with AWS KMS. You need to specify the organization ID in the condition element. Okay, so why is this correct? So the AWS Principal Org ID condition key, this simplifies an organization-wide access control by allowing you to specify the organization ID instead of listing all account IDs. So to automatically create includes all accounts under that ID. All right. Why are the other ones incorrect? So let's see. So service principal. Okay. So this condition cannot restrict AWS service principals as they operate from internal AWS accounts outside of organizations. And then let's see. List all accounts. Okay. While it's possible, this defeats the purpose of using the AWS Principal Org ID, right? Operational overhead. Okay. The Principal Org ID is used to eliminate the need to list each individual account ID. So imagine if you had 500 accounts, it would be very difficult to do all this. And if it's scaled up, even more difficult. And then Principal is AWS service. So this is used to check if calls are made by an AWS service principal. It's not for organization-based access control. Let's see if we can find. Let's see. Principals. Okay. Okay. So this allows the access. That's one section. Okay. Principal org ID. Okay. Use this to compare the identifier in the organizations to which principals requesting this belong to. It's an alternative to listing all accounts. You use this condition to simplify specifying the principal element in a resource-based policy. That answers it. So it includes all the correct accounts that don't meet this requirement, or that meet this requirement, excuse me. All right, we'll store that one. Perfect. All right, we're on to the next question. All right. Oops. All right, the security team at an e-commerce company has noticed that several EBS volumes are not encrypted. These unencrypted EBS volumes are attached to EC2s that are provisioned with an auto-scaling group and a launch template. You've been hired as a security specialist to implement a solution that ensures all EBS volumes are encrypted, both now and in the future. What do you recommend? Okay. This is going to be A. Leverage the EC2 console to enable encryption of new EBS volumes by default. Use the auto-scaling group's instance refresh feature to replace existing instances with new instances. So how does this work? So EBS encryption by default ensures all new volumes are encrypted, and an instance refresh provides a controlled replacement of existing instances to address current unencrypted volumes immediately. All right, so let's see, what are the other ones? All right. All right, so just natural replacement. This is weird. Okay, so all right, let's see. This is a strange statement. In due course of time. All right, this is a naturalistic issue. Okay. This doesn't meet the requirements for the immediate action on the existing unencrypted volumes. That's point blank, period. This is saying it'll just solve itself. If you broke your leg, it would just heal in due time. It's possible it'll just heal wrong. Modifying the launch template. Okay. So you can't modify existing launch templates. You have to create a new versions. Like you can have a launch template and then have version 1, 2, 3, 4, 5, 6, 7, whatever. And then you'd have a default set for whatever version you're using. Okay. And then let's see. Enable encryption by default, propagate this. Okay, there's no such automatic propagation feature in the auto scaling groups. That's just not going to happen. I mean, it's a distractor. It makes it, you have to know this a little bit clearer to understand this, but hopefully you understand it now. All right, go to the next question. A financial services company wants to share sensitive accounting data that is stored in an RDS database instance with an external auditor. The auditor has another AWS account and must own a copy of the database. Which of the following would you recommend to securely share the database with the auditor? There's going to be A, create an encrypted snapshot of the database, share the snapshot, and allow access to the KMS encryption key. So why is this correct? So encrypted snapshots provide secure point-in-time copies that can be shared across account. Sharing the KMS key allows the auditor to access the encrypted snapshot, meeting the requirement for the auditor to own a copy. So why are the other ones incorrect? A snapshot of the database in S3. Oof. So RDS snapshots are stored in AWS managed S3s, but users don't have direct access to these snapshots objects. Okay. Then exporting the database. So this is feasible, but this is not optimal. It's hard to audit it, and it's hard to verify the data integrity with a bulk text. And then read replica. So this provides access, but not ownership. The auditor doesn't get an independent copy they can control. Must own a copy of the database. All right. And this will be here. Sharing a snapshot. Whether encrypted requires authorized AWS accounts. Encrypted snapshot. Yeah. This is going to be the page. And here are the instructions here for this. All right, we'll go to the next question. All right, a media company uses S3 to store the images uploaded by the users. These images are kept encrypted in S3 by using AWS KMS, and the company manages its own customer master key for encryption. A member of the security team accidentally deleted the CMK a day ago, thereby rendering the user's photo data unrecoverable. As an AWS security specialist, you've been tasked by the company to provide a full solution for this issue. Which of the following would you recommend? A, remember that 1 day ago. Since the CMK was deleted a day ago, it must be in the pending deletion status. And you can just cancel the CMK deletion and recover the key. All right, so why is it correct? So KMS enforces a waiting period of 7 to 30 days. Default is 30, right, before actually deleting the CMKs. So during this period, the key in the pending deletion status and deletion can be canceled to recover the key. So why are the other ones incorrect? AWS support, that's not going to happen. So AWS support doesn't have access to customer CMKs or maintain backups of them. What's the other one? Company should issue a notification on its web application. That's as unnecessary since the key can be recovered via the cancellation. You know that. And then the CMK, the root account. So root accounts can't recover deleted CMKs, and AWS doesn't have access to customer key material. And let's go over here to see this. Supporting documentation. Only proceed. Deleting a key is destructive and potentially dangerous. Before you delete it, you must have permission to do so. There you go. And then how you do this doing this. I don't see the 7 days portion. Let's see. Okay, while the waiting period, because it's destructive and potentially dangerous, requires a set a waiting period of 7 to 30 days. The default is 30 days. There you go. And then during the waiting period is in the pending deletion. Key cannot be used for cryptographic operations, and the KMS doesn't report. Boom. All right. And we'll go to the next question. All right. A retail company recently faced a cyber attack and lost all its data stored in the EBS volumes for the EC2 instances. However, the EBS snapshots were not manipulated. The company could restore the data from the EBS snapshots. However, the incident highlighted the security gaps in the current security plan. An immediate need is to protect the EBS snapshots from any manipulation or deletion. As a security engineer, what measures will you take to protect these AWS customer master keys encrypted snapshots? The answer is A. Create a new AWS account with limited privileges. Allow the newly created account to access the AWS KMS CMK key used to encrypt the EBS snapshots. Copy the encrypted snapshots to the new account on a regular basis. So why is this correct? So cross-account snapshot copying with restricted privileges provides isolation from the account compromise. And sharing the CMK allows the isolated account to access encrypted snapshots for protection purposes. So why are the other ones incorrect? Okay, so default encryption. Okay, you can't share snapshots encrypted with default EBS encryption keys. You can only share customer managed key encrypted snapshots. And then S3 bucket. So systems manager on the S3 bucket. Woo. So systems manager doesn't manage EBS snapshots or their storage locations. That's just a misleading question all around. And S3 lifecycle. So you can't use S3 lifecycle policies to copy EBS snapshots. Snapshots exist in AWS managed storage, not user accessible S3. All right. We'll go to the next question. All right. A security engineer has created a web ACL using AWS Firewall Manager, AWS WAF policy. Still, the web ACL isn't correctly associated with it in scope resources. What could be the underlying reason for this issue? So this is going to be A, if auto remediate any non-compliant resources isn't turned on, then the Firewall Manager created web ACL won't be associated with in-scope resources. So why is this correct? Without auto remediation enabled, Firewall Manager creates web ACLs, but doesn't automatically associate them with resources. Auto remediation is required for automatic association. So let's see, the replacements. Okay, so replace this and replace this. Okay, so B and D, why are these incorrect? So these are specific association behaviors that don't address the fundamental issue of whether auto remediation is enabled. Okay, and then this is, why am I looking? Where am I looking? Nope, that would be, I'm sorry, that would have been B and C. My apologies. And then this one, oh man, this is, okay, this is interesting for Shield. Okay, Shield Advanced. All right, that's what got this. Okay, so this is not a correct behavior. So the actual association behavior depends on the specific settings configured, right? And Shield doesn't work like this with Firewall Manager. All right, so that is the end of domain 5. Next, we'll be going over the final domain, management and security governance. Thank you for joining me. If you've enjoyed this, hit a like, subscribe, comment, or share. Thank you. Have a good day.